All right, everybody. So the next unit that we're going to be looking at in human geography is population. So actually, this is going to be population migration. So in this video, I just wanted to go over population in general, looking specifically at population distribution and population density, and what those two might mean for a country in terms of economic or social or political or environmental consequences. So let's go ahead and get started. So here's our enduring understanding, uh, knowing characteristics of human population, how it facilitates understanding of those things. So, all right. So let's take a look at a couple of pictures real quick. These are pretty neat. This shows both distribution and density. And so we're going to get to the definition here in just a little bit, but I'll, go ahead and tell you what it is real quick. So population density is how many people are living in a certain spot. So it's usually measured by, how many people per square mile. I think Tucson is around 2,100 per square mile, 2,100 people per square mile. And so that's how density is measured. Distribution is where those people live. And so if you take a look at this map, this kind of shows us both because it shows us over here, here's where people are living, and it also shows how many people are living here. And so with this kind of graph, the higher the spike, obviously the more people. And so you can see this is India. And so obviously distribution and density are both very high there. And we'll look at India more specifically in just a little bit. So let's take a look. So this is the U.S. And this is, again, these are really cool maps to look at. So this kind of shows you where, so the distribution of where everybody is. And so if you take a look at this, 80% of the people in the U.S. live on, it's actually 80% live east of the Mississippi River, which is somewhere in here. And so it's probably not exactly right, but get the idea. And so somewhere around 80% of the people live in this area, which means 20% live over in this area. And so that's the distribution. Now, when we look at density, obviously we have New York here, which is the most dense place in terms of people per square mile. But then we start to look, where else in the country is it? Obviously, San Francisco's big, LA is big, Seattle's kind of big. Here's Phoenix, and this would be Tucson. And so this shows you both distribution and density. And take a look at Florida. So there's certain parts of Florida where not many people are. Then there's other parts where people live a lot. All right. Here's Chicago up in here, Detroit. And so you can kind of see here's, this is a big population center for the U.S., Atlanta there. So anyway, it's a neat map. It's a neat visual to kind of get a context of the distribution and the density. All right, so this is China. And note, the majority of people, just like the US, the majority of the people live east of this line. All right, and so have a high population center there. Here's Wuhan, familiar with that just from the virus. Shenzhen, Hong Kong is here. And so very high, obviously Shanghai. So again, it shows you where people are living in China. Not a whole lot of people in these areas. So it shows us where the distribution is, but also the density. All right, so there's Beijing up there. Let's see, this is India. And so there are some spots within India where a whole lot of people aren't living. But if we look here, this is the huge, this is where a bunch of people live. All right. And so, obviously the distribution is spread pretty evenly throughout, except maybe in this area here. But the highest population density for India is up in this range. All right. This is showing us, I guess, Southeast Asia. So Ho Chi Minh City. Here's Bangkok up here. This is Indonesia down here. So you can see a very high concentration there. Not many people there. And so, again, distribution and density. All right. This is a pretty interesting quote here. Half the world's population lives in just 1% of the land. And so that would be, a distribution density thing as well. And so let's take a look at the definitions real quick. And by now, I'm sure you have an idea what's going on. So again, population distribution is the pattern of human settlement. All right, the spread of people across the earth. This is telling us where they live. All right, and then density, the measure of the average population per square mile. And so if this is the where over here, then this is the how many over here. All right, so distribution where, population density, how many. So let's watch this little video. This is showing population growth. So it's going to give us distribution and density as well, starting in the year, I think, year 1, CE, and then going up to the present. So as we go, I want you to take note that this is what they call a hockey stick growth. So think of a hockey stick laid down. I'm losing my marker on this since it's a video, but think of a hockey stick laid down. Hopefully you can see the pointer. The population grows really kind of minimally in the beginning, and then it takes off. All right. And so you're going to see that the distribution is going to stay similar because remember, and we'll get to this more in just a bit, people are going to settle and locate where it's easiest to live, where there's plenty of food, plenty of fresh water. And there's going to be exceptions to that we'll look at. And so we're going to see these areas, the distribution is going to stay the same. We are going to see people spread out with exploration. Obviously the North and South American continent are going to become much more populated, but these areas that are dense right here, so here's 422 CE, these are going to be the same high population densities as we go forward. So let me go ahead and play this. It's just a couple of minutes, and they put some funny dramatic music to it. But anyway, here we go. Oh, hang on just a sec. Oh, shoot. All right, let's try that again. Nope. Sorry about that. Real quick. Let's see if this will load up.
An environment is a system of living things. The Earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface, and only about 4% will grow crops. We depend on these limited resources for our survival, yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present and project our growth into the year 2050. Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
Sorry about that. As this goes on, and down at the bottom you can see the year and what's going on during that time. As this goes on, you'll see that humans start to spread out across the globe, for one thing, so our distribution does grow. But again, take note at where the population is right now, and then watch how it just continues to grow a lot during that time. All right. Once we hit around 1800 or 1900, you're going to really see it start to grow. We'll talk about why that is. And this is not the video with the music. This is the one with the imposing heartbeat. Take a look over here. This is pre-Columbus. All right. So these are Native American tribes. This is where most people in the Americas lived, Mesoamerica. see these population centers, they've been the big population centers throughout the last 2,000 years. So the Black Death, you start to see some of these dots go away. Now we're going to start to see the growth. Now we're coming up on Columbus down here. All right. And the slave trade definitely caused a change in distribution. Now we're going to see it start to pop pretty big. So here's China and India. Europe's going to explode, and then the US. So notice the pace of growth. We're talking about why that is. So we're 4 billion, 5 billion, 6 billion, 7 billion, 8 billion. And so they think around 9 billion by 2050.
Our population is expected to grow to 10 billion by the end of this century. Yet the Earth's size remains the same. Slowing human population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our home.
See if I can get out of that. Alrighty, so let's get into some of the meat of this. So when we talk about why does population distribution matter, again, it's the ESPN variables. And so some of the things that we'll look at, and this is just an extraordinarily short list, but these are just some examples of what it would be. So if we talk about population distribution, you know, we need to figure out where to set the electoral districts, so the congressional districts in the U.S. So for us, that would be a good reason. We do that with the census and kind of figure out where everybody lives, where we're going to put housing developments, how resources are going to be managed, who's going to get those resources. It's also going to be critical in disputes, international disputes or regional disputes. And so, you know, distribution plays a big role in how we behave. Alrighty. It has increased significantly. All right. Whoops. Population density, I'm sorry, has increased significantly, but not necessarily distribution. And again, that's because people settled where it was generally easier to live. Not everybody, obviously, but generally speaking, people are going to settle where they have access to food and access to water, and it's relatively safe. All right. And so when we talk about distribution, that's, you know, why do people settle where they do? That's the reason. So take a look at this map. This is a distribution map. Each area, so just my pen. So this whole area is 1 billion people. All right. Here's a billion people. Here's a billion people. Here's a billion people. And so you get the idea. And so this is showing us, you know, by area. And so again, when we look at China, you know, China and India are by far the most densely distributed population areas in the world. All right. And here's China as well, and Indonesia. All right. So again, population distribution, 2/3. So this is where everybody's located. And again, this gives us distribution and density, because if you look down here, if you look down here, this shows us persons per square kilometer. And so as we get to the purple, it's 1,000 and above. And so we can see, you know, a bunch of people here. Here's some of the purple areas, a bunch of people here, a bunch of people in the U.S. up there. And these jive with the maps that we looked at the very beginning of this presentation. So a bunch of people down there as well. All right. So 2/3 of the inhabitants, Earth's inhabitants, are in these 4 areas: East Asia, South Asia, Europe up here, and then Southeast Asia. All right. Here's population distribution and density again. This is a cartogram showing us relative size, and so India and China are the biggest countries on Earth in population. The U.S. is actually third in population. All right, so this graph is showing us the relative size in a cartogram. So some of the physical factors of where people live. So let's go over these real quick. So obviously, reliable food and water and shelter is going to be the key to figuring out where to live. And so today there's not a whole lot of difference. We generally live in those same places that people established before. All right. Now, most people do live in the mid-latitudes. So let me go forward real quick. So this is what we mean by mid-latitudes. This area, so let's see. So between these two spots, that'd be a mid-latitude area. And between these two spots would be a mid-latitude area. They generally try to avoid this area because of weather. All right, and so obviously more people live up in the northern mid-latitude, I guess you would say, than the southern, just because there's more landmass up there. So let's go back. Low-lying areas are another physical feature that people would look at, and that's because they have better soil and they're often close to oceans, which is good for multiple things: transportation, food. Oceans moderate temperatures, and so that definitely helps. Also, access to fresh water is going to be a big one, and then any other kind of natural resources that people would find. And so when we talk about the physical factors that cause people to live where they live, that's them. Alrighty. So these would be pictures of places that people have not settled for obvious reasons, all right, because the physical factors are not that great. That one's pretty funny with the frog looking like he's holding an umbrella. So, but these would be pictures of things that people would look at and say, okay, this would be a place to live. So pasture land would be there, living by the water, access to fresh water, good soil. You get the idea. So those are physical factors that people would be happy about. All right. Some of the human factors, and so there are different reasons that people move. It's not just physical factors. A lot of it is today, especially because of transportation and communication. You can live on areas that aren't necessarily suitable to living in a self-sustained way because you can import stuff. All right, and so a lot of reason that people move, and you can relate with this, could be because of a job, could be because their friends or family live in a certain place, and so there are a lot of different human reasons that would come into this. All right, the people themselves might be an attraction. You might like the idea of moving to New York or San Francisco or to Wyoming because of the people that live there. All right, we also enjoy living close to trade routes, so transportation, roads, train lines, all that stuff. And there could be some political decisions as to why people live where they live. There was a Canadian military base called Alert, which is the northernmost, a northerly community. The most northerly community, one of them in the world, and that military base was established so the Canadians could keep an eye on the Soviet Union. So that could be another reason for distribution. Alrighty. So we want to look at, this is the next section and last one for this video. We want to look at a couple of different ways of calculating density. All right, and so there's going to be three types. There's going to be arithmetic density, physiological density, and agricultural density. So arithmetic density, it's a very simple measure. It just says how many people are living there and divide that by the area. All right, and so the U.S., and you can either do this in square miles or miles squared or kilometers. All right, and that's how you're going to see it, one or the other. And so when you look at the U.S., we take the population, and this is actually 335 million now. And so we take the population and then divide it by the square miles, and that would get us that number. So if we just looked and said, okay, here's 335 million people, here's our square miles, we have about 83, 84 people per square mile. That is an interesting number in one respect, but it doesn't tell us a whole lot, because if you remember back to the beginning of the video, when we looked at the US, like 80% lived east of the Mississippi. And so here's the idea. The arithmetic density is an interesting number, but it doesn't tell us anything about where people are living. It doesn't tell us any kind of distribution. And so it is, is it evenly distributed, clustered, or is it some kind of linear pattern? And so we don't know that from this number. All right, and that's the weakness of arithmetic density. But this is a map showing arithmetic density. Obviously, China, or I'm sorry, India over here, China there. We've got some of the Northern European countries, or the Western European countries, sorry. And so look at the U.S. You know, the U.S. doesn't look like it's, you know, it doesn't have a whole lot. And so this is per square kilometer, so that's why we were 84 per square mile, so it's a little bit less for square kilometers. But anyway, this gives you an idea of per country, how many people are in the country in terms of its land size, but doesn't tell us a whole lot of other stuff. The other type of density that we look at is something called physiological density. And this just means, you know, within your country, how much arable land, and by arable land, we mean land that can be used for growing things, how much arable land is there to sustain the population. All right, and so physiological density takes the population and divides it by the amount of arable land. And so if you look at a country like Egypt, obviously Egypt is mostly desert. You can see over here this green area would be the arable land. And so Egypt doesn't have very much arable land, 2.8%, and they have a high population. So their physiological density, this would be like 8,078 people per square mile of arable land. And so the higher that number gets, the more strain it's going to put on that farmland itself. All right. So their arithmetic density, you know, if we take a look at their total size, the population divided by the total area, looks very low, 226. But when we look at compared to their arable land, it's much higher. And so that could, again, put pressure on that land. All right, so this is people per square kilometer of arable land. And so again, we're looking pretty good in the US over here. Obviously, Egypt is pretty big. And so you see some of these countries, India over here, some of these countries have some issues with their population size compared to their farmland. All right. It also gives us some implication of this thing called carrying capacity. So what is the carrying capacity of the land? And carrying capacity just means how many people can that land sustain, all right? And so not all countries are going to be the same because some have different technologies or better technologies, and they can carry more people per square mile, basically. But this is a number that's looked at often. Okay, what is the carrying capacity of that land? And if the population outstrips the carrying capacity, one of two things has to happen. One, people are going to have to move, or two, they're going to have to figure out a way to get the food. And so obviously it's easier today because we import a bunch of stuff. All right. And so then the last one is what they call agricultural density. And agricultural density, again, we're looking at arable land, and agricultural density says how many farmers per square mile or per square kilometer of arable land. All right. And so lower here is generally considered better. And so you'd say, look, let me go to, I think I lost a slide. Hang on. Sorry. So I just skipped over it. So if we look at developed countries have a lot more technology. And so if you think about farming today, how many farmers does it take to farm 100 acres in the US versus how many does it take to farm in Bangladesh? All right. And so to have fewer farmers per square mile is considered a sign generally of more developed country. All right. And so take a look. More farmers per square mile, again, would indicate that they have less technology. And so these are the areas, the dark green would show us where that less technology is or more farmers. And the lighter areas would just mean that, hey, we don't have as many farmers in this area. Again, we used to have in the US around 1900, something like 50% of the people were engaged in farming. Today I've seen two numbers, I've seen 3%, and I've seen 1%. And so we don't have many farmers, but the technology allows us to produce way more food than we need. We're the world's biggest exporter of food. So you can take a look at this, this chart. Obviously it's got arithmetic density, physiological, and agricultural density. And so then it shows the percentage of farmers and percentage of arable land. And you can just kind of start to compare countries. Agricultural density here is 2 for us, 826 in Egypt. And so again, remember, the higher the number, generally the less developed that country would be in terms of agriculture. All right. And you could pause this and start to take a look, but that's kind of the idea. And this will show us arable land over here. All right. And then we will leave it at that for today. So have a great day.